All right, hi guys. Just thought I would come in. We're going to do a really quick set of class notes, which is a complete review of characteristics of functions and a little bit of review of polynomials thrown in just to kind of remind you of some important features that you need to know. And there's going to be a lot of this that you're going to work on your own. I've done a lot of pre-filling in of the notes. You're certainly welcome to copy this set of notes, this framework, print it out for yourself so that you can just follow along. I will pause while you do that before the video starts. All right, so you can see here in the handout, the first one has the kind of framework with a few extra things that you're going to fill in for me, and then I just put the key down here right below it so that as I fill it in, you will have the blank one to fill in for yourself. All right, so what we're going to do is we're going to take a look at a little bit about polynomials, and the idea here is that we should be able to determine what type of polynomial we have simply by taking a look at it. I did fill in some things that I want you to look at, things that you should be able to identify. One, you should be able to tell me what the real zeros are in the multiplicity. So like for this one, I would say that we have x equal to 0, which has a multiplicity of 1 because it crosses like a line, and x equal to 3 because that has a multiplicity of at least 2, multiplicity of at least 2 because it bounces, okay? And so the idea here is that we're talking about that typically polynomials that only have real zeros. We're kind of ignoring complex zeros for a lot of our discussion that we have. So this is going to give me some information about what the degree of this polynomial is. The other thing that I look at is the number of relative extrema or turning points. So here and here, there are 2 relative extrema in this graph. And you'll remind yourself, like, all of this has to do with what do we know about the degree? And the degree then here is always 1 more than what the number of relative extrema is. So it has to be greater than, in this case, 3. Up here, if I'm looking at, kind of highlight this as I'm thinking about it, when I look at my real zeros and their multiplicity, if you add up the multiplicities, okay, which we have, what, 1 plus 2, that's going to give me 3. Again, this gives you the min number or min degree, okay? So that's one way of looking at it. Now, a lot of this has to do with saying it's the min degree because remember that we haven't counted complex zeros, if they may have those. And this multiplicity of at least 2, really what you know about that is an even multiplicity 0. We don't. It could actually be a multiplicity of 4. We just don't know. We're just saying that it's at least 2 because of the behavior of it. We also take a look at our end behavior, and we see that the end behavior is going in opposite directions. And what that tells me when the end behavior goes in opposite directions is that the degree must be odd. All right, so that's our kind of answer down here below, degree, even, or odd. The answer is odd. So I can tell that simply by looking at what the end behavior is actually doing. And so based on this information, this is very clearly the degree of this polynomial is at least 3. So degree is greater than or equal to 3, and it is odd. And so typically, if I was going to identify this, I'd probably classify this as a cubic as the minimum of what it is. And like I said, and maybe a little bit later on, we'll talk more about things that are higher power that don't exhibit like maybe complex zeros, if we can fit that in this year. But for what we're doing, this is going to be enough. All right, I'm going to leave G and H for you to do on your own. So you can come back and check the key later to do that. Let's go down. So let me just put on your own. On your own here. So fill that in. All right, let's come down here. Now the rest of it has to do with characteristics of functions. And this is something that we've already talked about this year. And so it's just kind of reminding you of some important kind of facts about characteristics that we want to talk about. We already know a relative maximum is any point on the graph where f changes direction, and it's switching from increasing to decreasing. So we see on this side we are increasing, then we are decreasing after. So this point right here is going to be a relative, I'm doing relative max, and so relative max. I just realized when I look down here at my words, I put min right there, so we'll change that. Now, remember that when you're doing this, and this has to do with what I have over here in red, that the point, if they ask for the point, would be AB. So I can fill that in down here. The point of the max is going to be 1, 4. But we also sometimes are going to separate out that the max value is actually the y value, and the location of the maximum is usually the x value. So our max value of 4 is occurring at x equal to 1. So those are kind of the different ways that we would see that. All right, I'm going to leave everything over here in this column to be on your own. So give those a try down below for this one. And I'll just do another arrow for the one over here. Relative minimum, same thing. The only difference is it changes from decreasing to then increasing. And so this one, the point is 3, -3. So and I had those backwards. I obviously wasn't reading when I was doing this. The min value is going to be -3, and it occurs at x equal to 3. All right, then we get down to something like what is an absolute minimum. And that's going to be the point on the graph that has the smallest y value in the range. Now, in this one, you be prepared. It has to actually be an actual value, an actual point on the graph. And infinity is not a point on the graph. So for this one, this has no absolute min. And another reason I know this is because my range is -infinity to infinity. And so we can see right here that there is no lowest or smallest y value. And so you have to kind of have a bracket and a value at the bottom of the range in order to have an absolute minimum. And so if I'm looking at this one, the lowest value on the graph down here is occurring at -3. So the absolute min point is going to be 2, -3. And then I would say that the absolute min value is -3 at x equal to 2. And again, kind of showing you the difference, the range in this case is going to be -3 to infinity. And we can see right here we have a bracket and a number, and that's what's telling me that I actually do have an absolute min when I take a look at that graph. All right, the only difference here is that the absolute max is the largest value. I'm going to leave this for you to do on your own and fill that in and check with the key as you go. All right, next thing we want to talk about to remind you of are points of inflection. And a point of inflection is any point on the graph where the graph changes concavity. Concavity curves up versus curving down. Let's put that in red. Curves up to curves down, or vice versa, okay, on that. We've talked about this before. The function itself may be increasing or decreasing, but we're looking at the rate that the function is increasing or decreasing. And that rate is going to switch from an increasing rate to a decreasing rate. And so it's kind of like, how was the function going up or going down? Was it going up faster with a steeper slope, or was it going up slower with a less steep slope as you go around? There are 3 places where this can occur. Obviously, a 0 with odd multiplicity, which is kind of how we defined, how we knew we had odd multiplicity. And if graphs are smooth, which no jagged edges, no discontinuities, anything like that, if graphs are smooth, typically you're going to have a point of inflection somewhere in between a max and a min. Now, I will say I kind of put over here on the side that this point of inflection that we're looking at here, I highlighted it right there, that the point of inflection that's somewhere in between the max and the min, in pre-calculus, we can only estimate or guesstimate where they are. We actually need calculus in order to determine the location of a point of inflection. So typically, if you're asked this question, you are going to be allowed to simply estimate from the graph, or you can, or you may be given the point and said this is a point of inflection. Sometimes what people do is their estimate for the PLI, they sometimes use the midpoint between the max and the min, because that's always a good estimate. It's not, but it doesn't necessarily have to be that. So we'll just say could use x equal to the midpoint of the max and min locations, but that's not even necessary. And typically we'll go through, a lot of these are fairly nice, and it should be pretty easy to kind of estimate where those points of inflection are. And then the third place that I wanted to put where it could occur is at a cusp in the graph. Just to kind of remind you, a cusp would be something where it's maybe curved and then it comes over and it's got this little pointy little edge to the graph like that. However, I did put a comment that in the polynomial and rational section, which we're reviewing right now, polynomials never have cusp. It does not happen in these types of functions. Polynomials are always smooth and continuous. All right, so, one of the things you're looking at this is like, how many points of inflection does a graph function below have? Basically, you're just going by looks like, and you should be able to identify them. Like if I'm looking at this right here in between these values right here, you can see that this is curved down to somewhere maybe about, like, and we're estimating kind of what it is. And notice that I kind of am looking at it, and I could use the midpoint, but I feel like it's somewhere kind of about right there. So I'm just picking a nice value and saying that that looks like a point of inflection to me. We clearly have an odd multiplicity 0 right there, so that would be another point of inflection. And then also notice here, in this section right here, I'm doing a little bit in orange. You see how it's curved down right here, okay? And then somewhere it's going to switch and become curved up somewhere right here. So I'll put that in green. Let's just do everything. This is curved up, and then orange, this is curved down when you're looking at it. So somewhere in there, and again, we're just estimating. So I'm going to go with, actually use the midpoint and say that it's at that value right there. So if it says how many points of inflection does it have, it very clearly has 3 points of inflection on this graph. And then could we label and identify all the points of inflection for the graphs below? Yeah, sure. Remember, we're estimating. This is an estimation. This is not an exact value for you guys here in pre-calculus. So for this one, I would probably say -2 and 1.5. I would say 0, 0 is a good one. And then the third one looks like it's about 2 and -1.5. And this is also one of those things you'll notice this graph has odd symmetry, so that kind of is helping me out in picking those. All right, so these two over here are going to be on your own, taking a look at it. All right, now when we start to talk about open intervals for the x values, the graph either curves up or curves down from the tangent line. And so it's just this idea of we're just giving the values. Again, here's going to be a section that's concave down, and here's going to be a section that's concave up. So we would answer this question and say concave down for -infinity to 2, the point of inflection, and concave up for 2 to infinity. So pretty straightforward. And again, I'm going to let you do this one on your own and check with the key. All right, and then to finish out this last part of the video, this problem right here, I'm going to go ahead and put the key to this up as well, but this is like putting it all together, and I want you to go ahead and fill this out. So I'm going to pause the video and come back with the answers to talk about. You guys try it on your own. All right, check your answers for this. I highlighted 2 things. The use of union in the greater than and less than versus the no union in the increasing It's not appropriate in the increasing. And then also in blue, that those are estimates and that your answers may vary slightly from those. So if you have any questions, shoot them out to me, do the last problem and the homework.